Hello learners and welcome back to Constant Learners. In the previous video we started with logistic regression. We discussed why logistic regression is used to solve classification problems and why we cannot use linear regression for the same. We also discussed how we can use sigmoid function to map the data for logistic regression, and in this video we are going to discuss furthermore why we use a sigmoid function to map the data for logistic regression and how we can transform our data from probabilities to log of odds. That means rather than using sigmoid function, how can we use log of odds to map our data, and why do we need to do so? Okay, now see on the screen you can see a figure wherein we have logistic regression wherein the data is being classified to two categories, that is 0 and 1. Okay, on y-axis we have the probability of heart diseases and on the x-axis we have cholesterol level. Now see, if the cholesterol level is above 240 milligrams, then the person definitely has a heart disease, and if the value is below 240 milligrams, then the person does not have a heart disease. Okay, this line is considered to be the line of best fit. What is a line of best fit? Line of best fit means it maps the data in the best possible way while minimizing the errors. So this is not actually the line of best fit. We are only assuming it to be the line of best fit to understand why we cannot use a straight line to map the data in logistic regression. So we are assuming this to be our line of best fit. If this is the line of best fit, then it will map the data in the best possible way while minimizing the errors. Okay. Now if we consider this data point, see, we know that in logistic regression 0.5 is the decision threshold. All the values above 0.5 will be considered as 1. That means the person has a heart disease, and all the values, that is the probabilities below 0.5, will be considered as 0. That is the person does not have a heart disease. Now if we consider this data point, it meets the line of best fit below 0.5, correct? That means this will be classified as 0. This point is also meeting the line of best fit below 0.5. That means this is also belonging to the class 0. Now if we consider this data point, it is meeting the line of best fit above 0.5. So this person will definitely have a heart disease. Now this data point is also meeting the line of best fit above 0.5. That means this person also has a heart disease. But now if I consider this data point, it is meeting the line of best fit above 0.5, but it is also going beyond 1. Are we allowed to go beyond 1 in logistic regression? No. Correct? Now if we consider these data points, these are meeting the line of best fit below 0. Are we allowed to go below 0 in logistic regression? No. So this is one reason why we cannot use a straight line for logistic regression. Alright. Now let me erase these and then we will come back to understand the other reason. Now see, if I move this line of best fit to some other direction, let's say in this direction. Okay. Now in this case, this data point, this person or this value which is above 240 milligrams of cholesterol level, this person should definitely have a heart disease. But now it is meeting this line of best fit here, which is below 0.5. So this person will be wrongly classified as class 0. That means he does not have a heart disease. Let's consider this person. Here this person should also be classified as having a heart disease because his cholesterol level is above 240 milligrams. But he is meeting the line of best fit below 0.5. So he will also be wrongly classified as he is not having a heart disease. Thus, if the line of best fit is wrongly drawn, then in that case, the classification will not be proper. So we can say that logistic regression is a complex function and it cannot be mapped to a straight line. Okay, because in linear function, the output goes beyond 1 and below 0. but that is unacceptable. See, here also it is going above 1 and below 0. But this is unacceptable in case of logistic regression. And thus, we use a sigmoid function like this one. Thus, we use a sigmoid function to classify our data, or we can say map our data in case of logistic regression. I hope this much was clear. So now we know why we are using a sigmoid function. Okay, sigmoid function is not a linear function. Okay, rather it is an S-shaped curve like this one here. Okay, to map the probabilities, we know that on y-axis here we have the probabilities. So sigmoid function is used to map the probabilities. This is very important. Okay, and we know that logistic regression should have the range between 0 and 1. We have to classify the data into two categories, that is 0 and 1. Logistic regression, the data values cannot go above 1 or below 0. And sigmoid function has the capability to map the values in the range of 0 to 1. That is why, see, both are interchangeably solving the problems. Correct? Sigmoid function maps the range or the value in the range 0 to 1, and logistic regression requires the range 0 to 1. And thus, we use sigmoid function for logistic regression. Okay. Now, what is a sigmoid function? The formula for sigmoid function is 1 upon 1 plus e to the power minus x. Okay. In case of x is equal to minus infinity, the sigmoid function becomes s of minus infinity is equal to 1 upon 1 plus e to the power minus of minus infinity, which will become plus infinity. So we get 1 upon 1 plus e to the power infinity. And when we solve this, we will get the answer to be 0. Okay. So when x is equal to minus infinity, the sigmoid function becomes 0. Correct? Now when x is infinity, s of infinity is equal to 1 upon 1 plus e to the power minus infinity. And when we solve this equation, the answer that we get is 1. So when x is infinity, the sigmoid function maps the values to 1. Okay. And when x is equal to 0, s of 0 is equals to 1 upon 1 plus e to the power 0. So any number to the power 0 is equal to 1. So e to the power 0 will also be equal to 1. So here we get 1 upon 1 plus 1, that is equals to 1 by 2, which is equal to 0.5. Okay. So when in a linear function, suppose here we have a linear function, whatever values we have at plus infinity will be mapped to 1 in sigmoid function. Whatever values we have at 0, suppose this is 0. Whatever values we have at 0, this will be mapped at 0.5 in sigmoid function. And whatever values we have at minus infinity in linear function will be mapped to 0 in case of sigmoid function. Okay. So in linear, wherein, see, for linear functions or linear equations, when the value is infinity, when the value is minus infinity, and the value is 0. In case of sigmoid function, the same value will be, for infinity it will be 1, for minus infinity it will be 0, and for 0 it's going to be 0.5. Okay. So this is how linear and sigmoid function can correlate to each other. Okay. I hope this much was clear. Now let's head to the next point. We know that sigmoid function is used to map the probability. Okay. Or we can say the sigmoid function uses probability to calculate whether something will happen or something will not happen. So here on y-axis we have probability. Correct? Probability whether a person has a heart disease, that is yes, or does not have a heart disease, that is no. For 1 we consider yes, for 0 we consider no. Okay, so sigmoid function uses probability. That means probability of whether it will rain today or it will not rain today. Or we can say the probability of whether a person is COVID positive or he is not COVID positive. So here we are mapping the probabilities. Correct. Now in sigmoid function, we fit the data in the best possible way by mapping the probability. See, our purpose, the main goal of using the sigmoid function is to fit our data in the best possible way. Correct. But in case of sigmoid function, we are fitting the data in the best possible way by using the probability on y-axis. Correct. Now we can do the same thing using log of odds. That means rather than using probability on the y-axis, we can use log odds on y-axis. Correct? So we can say that we will try to fit the data in the best possible way using log odds of heart diseases. Rather than using probability of heart diseases, we are going to use log odds of heart diseases. Correct? So instead of probability, we will have log odds on y-axis. But in case of log odds, the data that is mapped at 1 in case of sigmoid function is mapped to plus infinity in case of log odds. Okay? The data that is mapped at 0.5 in case of sigmoid function is mapped to 0 in case of log odds. Okay? And the data that is mapped at 0 in case of sigmoid function is mapped at minus infinity in case of log odds. We will discuss this using formula. How we are getting these values, we are going to see that in the next slide. Now see, here suppose we say that here on the y-axis we have log odds. Okay, this is 0, this is suppose plus infinity, and this is minus infinity. Correct? Now these are the data points on our best fit line. Now this is not exactly the best fit line, but we are assuming this to be the best candidate for the best fit line. So this is our candidate line for our best fit line. Correct? This is not the best fit line right now. We are just starting with something. We have to start somewhere. So we are starting with this line. Okay? Now these points, these data points here are actually log odds of data. Okay? These values here are not probabilities. We are not mapping probabilities in this case. We are mapping log odds. So this is log odd of the data point. This is also log odd of the data point. This is also log odd of the data point. This is also the log odds value. This is also log odds value. And this is also log odds value. Okay. Now in case of log odds, we consider that any value below 0 is mapped to negative infinity. And any values above 0 is mapped to positive infinity. Okay. So if the log odds value is above 0, we assume that the event will occur. Okay. And if the value is below 0, we consider that the event does not occur. So here using log odds also we are classifying the data into yes and no. Correct? Using log odds also we are able to classify our data. Correct? Now we are going to find the log odds value, and we are going to check how the log odds can be changed to sigmoid function, and the sigmoid values, or we can say the probabilities, can be changed to log odds. Not sigmoid actually, sigmoid maps the probabilities. So we're going to see how log odds can be changed to probabilities and probabilities can be changed to log odds. Now before we understand what is log odds, let's understand what is odds ratio. Odds ratio is actually a ratio of odds of success to the odds of failure. Okay, so here in this case we can say it is the probability of an event occurring, that is probability of yes to the probability of an event not occurring, that is probability of no. Okay, now suppose if I say that there are 30% chances of me having a heart disease. That means there will be 70% chances of me not having a heart disease. Now, how did I get this 70%? 100 minus 100% minus 30% is equal to 70%. So, in this case, what am I doing? I am subtracting 100% minus the chances of yes, correct? Which is equal to the chances of no. Similarly, in case of probability, if I say there's a probability of 0.3 that I have a heart disease, then there will be a probability of 0.7 that I do not have a heart disease, correct? So how can I find this? 1 minus 0.3 is equal to 0.7, correct? So I can say the probability of me not having a heart disease is equal to 1 minus the probability of me having a heart disease, correct? So here I can change this as the probability of yes upon 1 minus probability of yes. The probability of no is nothing but 1 minus the probability of yes. Okay, so this is the odds ratio. Now, if I take log of this ratio, we call it as log odds, which is nothing but log of P of y, because on y-axis we are having the probability upon 1 minus P of y. Okay, this is also known as a logit function. Okay, this is nothing but the logit function. Okay, now see, this is our sigmoid function, correct? This is 0, this is 1, and here somewhere in the middle we have 0.5, correct? Now let's consider, if suppose P of y is equal to 0, then P of y is equal to 1 and P of y is equal to 0.5. Let's find out what will be the values of log odds in all of these three cases. So log odds is equal to log of, when P of y is 0, 0 upon 1 minus 0. So we get log of 0. Okay, 0 divided by any number is 0. Now log of 0, if base is greater than 1, the log of 0 is equal to minus infinity. Correct? So when in sigmoid function, when the probability is 0, then in case of log odds, the 0 will go to negative infinity. Okay? Now if P of y is equal to 1, that is if the probability is 1, then in that case log odds will be equal to log of 1 upon 1 minus 1. So it will be 1 divided by 0. Any number divided by 0 is infinity. And log of infinity is nothing but positive infinity. So in sigmoid function, when the probability is 1, in case of log odds, the value will be plus infinity. Correct? And when P of y, or when the probability is 0.5, then log odds becomes equal to log of 0.5 upon 1 minus 0.5. Correct? Which is equal to 0.5 upon 0.5. That is log of, which is equal to log of 1. And log of 1 is nothing but 0. So in case when probability is 0.5, log odds will be 0. Okay, so this is how we can identify that in case of log odds, when the value is above 0, the classification will be yes, or the data will be classified as yes. And when the value will be below 0, the data will be classified as no. So this is how we can use log odds to classify data using logistic regression. Alright, I hope that this much is clear. Now we can also find probability using log odds. See, here we used probability to find log odds. Okay. Now we are going to use log odds to find probability. Log of odds to find probability. Okay. So how can we do that? So now we have to find P of y. The formula is e to the power log of odds divided by 1 plus e to the power log of odds. Okay, now I'm not going to solve everything, just the easy one. When log odds, see, let's consider log of odds is equal to 0. Okay, in that case, what will be p of y? It will be equal to e to the power 0 divided by 1 plus e to the power 0. Now we know that any number to the power 0 is equal to 1. So here we'll get 1 upon 1 plus 1, that is equals to 1 upon 2, which is nothing but 0.5. See, here when the log of odds was 0, the probability was 0.5. That is what we are getting here. When log of odds is 0, the probability is 0.5. So I hope both of these formulae were clear to you. And now let's quickly discuss the three types of logistic regression. First one is binomial logistic regression, multinomial logistic regression, and ordinal logistic regression. As the word says bi, that means having two categories. Just like we saw, yes or no, true or false, odd or even, spam or not spam, right or wrong. When there are just two classes, we call it binomial logistic regression. If there are more than two classes, that is three or more types, three or more classes, then in that case we call it multinomial. But this the most important deciding factor is that these are unordered classes. These are not quantitative. That means they don't need to be related to each other. Okay, like yes or no, right or wrong. They can be any three classes, any three values. They don't have to be in a particular sequence or in a particular range. Then in that case we call it multinomial logistic regression. For example, to find whether a person has a heart disease or not, we can use weight as a a type. Then we can use age as a classification. We can use blood test as the classification. Okay, so in this case we call it multinomial logistic regression. Then in case of ordinal, ordered, when the target variables are ordered, then we call it ordinal logistic regression. For example, good, better, best, or we can say poor, average, good, and very good. Correct? Or we can say A, B, C, D. Correct? Or in case of pass and fail, we have grades, right? A, B, C, and F. Correct? So this is how, when the values are ranging in a particular sequence or in a particular order, we call it ordinal logistic regression. I hope that all of this was clear. I know it's a little overwhelming, but I tried to be as simple as possible. And if you still haven't understood, grab a chocolate and try again. And if you haven't watched the video before this one, that is the basic of logistic regression, then I would suggest please watch that video first. If you watch that video first, I'm sure this video will not make you feel this anxious. Thank you so much for watching. If you have any suggestions, please write them down in the comment section below. And happy learning.